But let's go ahead and see what you've got so far. The mean is just going to be found by adding them all together. So 17 plus 28 is 45, plus 23 is 68, plus 32 is 100, plus 25 is 125, divided by 5, gives us a mean of 25. Any questions on the mean? Okay, good. For the median? Of course, the first thing we have to do is put the numbers in order. Next, we find the position of the median. Well, we can just cross off the first and last. Get to the middle. 25 is our median. I didn't ask for a mode, but you can see that there are no numbers in this list that are repeated, so there would be no mode. So C for the mid-range. The largest number is 32. We add that to the smallest number of 17, and we divide by 2. Well, 32 plus 17 is 49, divided by 2 is 24.5. Slightly different, but still very close to our mean and our median. Next is the range. The range is just going to be the largest number, 32, minus the smallest number of 17. So we get a range of 15. The standard deviation is where the fun starts. Standard deviation, of course, remember, is a 6-step process. Step 1 is to find the mean. We've already done that. It's 25. Step 2 is to subtract the mean from each number. So we need to write our list down. We've got 17, 23, 25, 28, 32. And from each number, we'll subtract the mean of 25. So 17 minus 25 is negative 8. 23 minus 25 is negative 2. 25 minus 25 is 0. 28 minus 25 is a positive 3. And 32 minus 25 is 7. Now again, if we added these all up, that should add up to 0. And it does. Remember, those are what we referred to as the deviation. Step 3. Is to square each deviation. So negative 8 squared. Remember, when you put that in your calculator, you do have to use parentheses. Any number squared should come out positive. Negative 8 squared is 64. Negative 2 squared is 4. 0 squared, 0. 3 squared. 3 times 3 is 9. And finally, 7 squared is 49. Step 4. Those were called the squared deviations. So step 4 is to find the sum of the squared deviations. We add those all up. We have 68, 77, 86, 126 it looks like, is my sum. Step 5, remember, is the one we have to be careful on. This is a sample, so we're going to divide by n minus 1. Well, what is n? N equals the number in the set. So for this case, n equals 5 because there are 5 numbers in the set. So n minus 1 equals 4. 126 divided by 4 is 31.5. That would be referred to as the variation if you were asked for it. Step 6 gives us the standard deviation. To get the standard deviation, it is the square root of that result from step 5, the square root of that variation. The square root of 31.5 is 5.61. Any questions? Okay. I realize that process is no fun. The quiz, I think they make you in a couple of spots on the homework. I believe they make you do a standard deviation of like 7 or 8 numbers. On the test coming up on Tuesday, I wouldn't use more than like 5 or 6 numbers for doing a standard deviation. So we've talked about that mean, median, mode, range, standard deviation. We also talked a little bit about what the mean and the standard deviation are used for. And one of the things we could use them for is comparing a number to the rest of its own population. And the process we used with this is called the empirical rule. And the empirical rule involves the bell curve. Remember, the center of our bell curve is always the mean, median, or mode. They should all be the same. We're going to use the mean. And we go out in steps of a standard deviation at a time in each direction. So it ends up going 3 steps in each direction. Between the mean and one standard deviation, we find about 34% of the data on either side of the mean. If we were to keep going, between 1 and 2 standard deviations is about 13.5% of the data. If we go between 2 and 3 standard deviations, it's about 2.35%. And outside of 3 standard deviations is 0.15% on each side. Now, right now, this curve doesn't mean a whole lot because we haven't defined what population we're looking at. But these percents under the curve always stay the same. Those never change. Any set of data that's normally distributed or approximately normally distributed, those percents will apply. So now let's take a look at rent. You want to rent an apartment for your first job, and you look at the area you're trying to rent in and the size of apartment you're trying to rent. Let's say you want to do just a 2-bedroom, 2-bath. And in the area you're looking at, you look up and you see all of the apartments that are rented in that area that are 2-bedroom, 2-bath. The mean monthly rent is $530. The standard deviation of $40. What that means, the center of this curve is $530. That's the mean. Right there, the 530 from the mean. Each step we go to either side is either adding or subtracting the standard deviation. As we go to the left, to get to this point, we will subtract the standard deviation. So it's 530 minus 40. That would be 490. The next step, we subtract standard deviation again. So the 490 minus another 40 is $450. Take that 450 minus another 40. It's $410. Going to the right to get this one, it's the mean of 530 plus a standard deviation of 40. $570. Add that again is 610. Add it again, 610 plus 40 is $650. So where this comes in to help you is, let's say you ask the question, what percent of apartments, it's implied in there the what percent of 2-bedroom, 2-bath apartments, I just didn't want to write that out, have rent that are less than $450. Well, to answer that question, we find 450 on this graph. It's right here. Less than would be to this side here. If we add those numbers up, that adds up to 2.5. Well, only 2.5% of apartments have rent that's less than $450. So there's not many of them that are less than $450 for rent. What percent of apartments have rent that is more than $570 a month? Well, here's 570 right here. More than would be the right side. So it'd be adding up those percents. If we add up 13.5 2.35, and 0.15. Those all add up to 16%. So only 16% of apartments cost more than $570 a month. We might ask what percent of apartments are between $490 and $570 a month. Well, to do that one, we find here's 490. This is 570. We add up those percents in between there. 34 plus 34 adds up to be 68%. So 68% of apartments we would expect to be between the $490 and $570 per month. Does that make sense? Any questions on the empirical rule? The key to the empirical rule is just to draw out this bell curve when you see stuff like that. Whenever you're asked what percent do you expect to be between these two numbers or less than or more than these two numbers, if they give you a mean and a standard deviation, they're almost always talking about that bell curve and the empirical rule. Remember, these percents don't change. What changes are these numbers down here based on what the mean and standard deviation of your population is. Well, the other thing we talked about that used the mean and the standard deviation was the z-score. The empirical rule was for comparing numbers to the rest of their population. Z-score is for comparing two numbers to each other that are from different populations. Remember, the z-score was equal to the number minus the mean, and then that difference divided by the standard deviation. If I remember right, I believe we compared SAT scores to ACT scores. Let's compare here. Let's say that you have two employees. For the sake of being creative, we're going to call them employee A and employee B. And you decided that you are going to let go the employee that has the worst week this week. Employee A produces 840 units. Employee B produces 1,920 units. Does that mean that employee A is gone? Well, not necessarily. They have different jobs working in different departments. Let's say that for everybody working in the same department as employee A, the mean production was 1,450 units. The standard deviation was 200 units. For everybody that worked in the same department as employee B, the mean production was 2,430 units. With a standard deviation of 150 units. So to compare those, we have, it's called standardizing them to their own population. we calculate a z-score. The z-score is going to equal the number. So for employee A here, the number they produced is 840 units. We subtract the mean of 1,450 units, and then that's going to be divided by the standard deviation of 200. So 840 minus 1,450 is a negative 610. Divided by 200 is a negative 3.05. So the negative means that this number is below average. The 3.05 means it's 3.05 standard deviations below the average. If we were going back up this bell curve, remember this is 1, 2, 3 standard deviations. Their production is out here beyond the 3 standard deviations below the average. Well, let's look at employee B. Find their z-score. Their z-score is their production of 1920 minus the mean for that department of 2430. That'll be divided by the standard deviation for that department of 150. 1920 minus 2430 is going to be negative 510. Negative 510 divided by 150 is going to be a negative 3.4? So that means the negative means that this is also below average, but 3.4 means it's 3.4 standard deviations below the average, which means if I went up here to the bell curve, this is 3 standard deviations below 3.4 would be way out here. So who did worse? Employee B is the one that seems to be out the door. They did the worst job that week. Okay, so that is the empirical rule and z-scores that I promised I would review this week. The rest of what I wanted to do tonight is to review for that last Unit 4 test coming up on Tuesday. Remember, next week, Tuesday's Unit 4 test. That is the final assessment as far as grading your knowledge of the material. Next week, Thursday, is a cumulative final exam. But that exam is more for the purpose of evaluating the course than it is for evaluating you. The only way it would hurt your grade is if you don't show up. If you don't show up, it will drop your grade by a third of a letter grade. So that means if you're at a B minus, it would drop you to a C plus. Or if you're at a C, it drops you to a C minus. Either one of those, if you want to take them earlier in the day, you can. I will have them at your locations by the night before. So anytime on Tuesday, you can take that Unit 4 test. Anytime on Thursday, you can take the cumulative final. If anybody has any needs outside that, I know some people said they had things going on where they had to leave Thursday morning for stuff. Send me an email so I have it in front of me, and then I'll arrange for you to take that on Wednesday if you need to. But we'll do that on a case-by-case basis. Okay, so to review for this test, obviously the z-score and empirical rule are fair game. The mean, median, mode, standard deviation, and range are fair game. Other things we need to remember, and this is going back about 5 weeks. Is measurement conversions. How do we convert 380 centimeters into meters? How do we convert 7 pounds into ounces? How might we convert 3 gallons into liters? All these are relatively straightforward conversions. Remember, for the metric system, we have our chart. It's meters, grams, and liters in the middle. As we move smaller, it is deca, meters, decagrams, whatever, hectometers, hectograms, hectoliters, kilometers, kilograms, kiloliters. Going smaller units, it is decimeters, decigrams, deciliters, centimeters, centigrams, and centimeters, or centiliters, and millimeters, milligrams, and milliliters. So to convert from centimeters to millimeters, or from centimeters to meters, I should say, centimeters to meters is 2 spots to the left on the chart. Our decimal point moves 2 spots to the left. That's 3.8 meters. 7 pounds to ounces is not metric. When we're dealing with the standard measuring system, the way we did our conversions was to put it in a fraction, put it over 1, and use a conversion factor. The units we're getting rid of go on bottom. The pounds will go on bottom. That way they'll cross cancel out. So the units we're going to has to go on top. 1 pound is 16 ounces. Pounds cancel out. 7 times 16 is 112 ounces over 1. So that is 112 ounces. Gallons to liters is a standard into metric conversion. So we do it the same way as we do the standard conversion. It's 3 gallons over 1. We're going to put gallons on bottom and liters on top so that the gallons cancel out. 1 gallon is 3.79 liters. Gallons cancel out. On bottom, it's 1 times 1 is 1. On top, 3 times 3.79 is 11.37 liters. Where you have to be careful. If we have 4 feet going into inches, that's relatively straightforward. Most of you don't even have to do the conversion factor to know you're just going to multiply the 4 by 12 to get 48 inches. The part that you got to be careful about is this part. What's different here? It's not feet being converted into inches anymore. It is square feet converted to square inches. So 4 square feet, we make it a fraction by putting it over 1. 1 square foot is how many square inches? Well, remember, a square inch, a square foot, is 1 foot by 1 foot. So that'll be 12 inches by 12 inches. 12 times 12 is 144 square inches. So the square feet cancel out. 4 times 144 is 576 inches squared. And of course, if we can have square feet and square inches, we can deal with cubic feet and cubic inches. For cubic feet, I'm going to put cubic feet on bottom and cubic inches on top. 1 cubic foot, for square feet, it was 12 times 12. For cubic feet and cubic inches, it's 12 times 12 times 12, or 1,728 cubic inches in 1 cubic foot. So the cubic feet cancel out. 4 times 1728 is 6,912 cubic inches in 4 cubic feet. So word of warning to be careful with those conversions. Make sure you look for the squared or cubed or anything like that. From measurements and measurement conversions, we moved on to angles. Given a whole angle of 48 degrees, and that this angle here is 12 degrees, this angle up here would have to be, if I called it x, well, x plus 12 adds up to 48. X has to be 36 degrees. Remember, because these angles are adjacent, they share a vertex and a side, the angles are additive. The two smaller angles have to add up to the bigger angle. We had special relationships with those types of angles. One of those was supplements. I asked you to find the supplement of 19 degrees. How are we going to find it? Well, supplements add up to 180. So 180 minus 19 is 161 degrees. That is the supplement of 19 degrees. So of course, if we're talking supplements, we'll also talk complements. The complement of 73 degrees. Complements add up to 90 degrees. So that'll be 90 minus 73 degrees is 17 degrees is the complement of 73. You might have something like this, where I ask you to find that angle. How would we find that angle? Well, that angle there is going to be the same as this angle here. It's also going to be the same as this angle here. Remember, when we have parallel lines cut by a transversal, the angles come in sets of 4. Well, where's the fourth angle that's equivalent to x? That's right there. The size of that angle is 32 plus 90. Perfect. That'd be 122 degrees. From there, we talked about similar figures. Similar figures were figures where one was an enlargement or reduction of the other one. How do we tell what matches up? Well, we have to look at equal angles. Draw this a little bit better, maybe. It's a little bit better. So if I tell you that those two angles are the same, and those two angles are the same, we know that the third angle has to be the same. If I give you that this side here is 25 inches, this one we're going to call X. This one we're going to call 20 inches. Over here, let's say that this one is 4 inches. We're going to call that one Y. This here is 10 inches. One of the things I like to do that makes these easier for me is before I do anything, I match up the corresponding sides. For every side in one figure, in this case triangles, so for every side in one triangle, there is a corresponding side in the other triangle. So the 20 inches corresponds to what side in the other triangle? The Y. Because it's between this angle and the one that isn't marked, between this angle and the one that isn't marked. It's between the same two angles. The 25 corresponds to what side in the other triangle? The 10, again, is between the one arc angle and the two arc angle. The one arc angle and the two arc angle. Between the same two angles in the corresponding triangles. So that leaves, of course, that the X must correspond with 4 inches. Now, to do anything to find those missing sides, we have to have a set of corresponding sides where we know both numbers. In this case, that's the 25 and the 10. Does not matter which one we put on top or bottom. I'll put the 25 over 10. If we are trying to find X, is X going to go on top here or on bottom? Remember, our proportions are all about relationships. It goes on top. It is from the same triangle as the 25, so it goes on top with the 25. What goes below it then is the corresponding side from the other triangle, which is the 4. Good. So we cross multiply. 25 times 4 is 100. And then we divide by the 10. X is 10. This is 10 inches. To find Y, we start out with the same setup. 25 and 10 still correspond. The Y is going to go top or bottom? Bottom, perfect. It is from the same figure as the 10 inches, so it has to go on bottom with the 10 inches. What goes above it? $20, good. The corresponding side from the other triangle is the 20 inches. So now we cross multiply and divide. 100 or 10 times 20 is 200. Divided by 25 is 8. So Y is 8 inches. Also dealing with triangles, we had our Pythagorean theorem. A squared plus B squared equals C squared. If we have a right triangle, we can use that to find the missing side. Or if we have just a regular triangle, we can use that to test to see if it's a right triangle. For example, if this is 11 feet, this is 59 feet, and 62 feet. And I want to test, is this a right triangle? Well, which side would have to be side C? The 62, the longest side. So the other two are A and B, doesn't matter which one's which. So we have to test, does that make this equation true? So A is 11, it'll be 11 squared plus B is 59, that'll be 59 squared. I'm not putting an equal sign here. I'm going to compare it to the 62 squared. Well, 11 squared is 121. 59 squared is, what is that, 3481? Yes, 3481. How about 62 squared? I believe it's 3842.44. Okay, 3844. Now let's compare. If we add these up, that is 3,602. That is definitely not equal to the 3844. So this is not a right triangle. It is our break time, so let's go ahead and take our break. We'll come back at 4:30 and we'll keep. So moving on then from our Pythagorean theorem, our right triangles, we have perimeter and area. Remember, for perimeter, we're just adding up all the sides, all the edges around an object. For area, we're actually finding the amount that it covers up. So let's take a look at a parallelogram. This parallelogram, this dimension here is 8 feet. This here is 17 feet. And up here, let's say that this is 25. Let's make it easier on ourselves. 26 feet. Find, first of all, the perimeter. Well, to find the perimeter, we just add up the sides. We have 26 feet here, plus 17 feet here, plus 26 feet here, plus 17 feet here. We add those all up and it comes out to be 86 feet of perimeter. For area, remember, for area, we need to multiply two perpendicular dimensions. So we can use the 26, but what we need is this dimension here. To find that dimension, we use the fact that this is a right triangle. Now there's the right angle, so 17 here would be C. That means these other two sides are A and B. So A squared plus B is going to be 8, so 8 squared equals C is 17, so 17 squared. A squared just stays A squared. 8 squared is 64. 17 squared is 289. We solve for A by starting out by subtracting 64 from each side. Gives us A squared is 225. And then we square root. Gives us A is 15. So up here, A is 15 feet. So that area is going to be 26 feet times 15 feet, otherwise known as 390 square feet. Any questions on that one? So here we have a rectangle with a half circle on top of it. This is 8 inches here, 15 inches to there. To find the perimeter, we have 15 plus 8 plus another 15 plus, we got to figure out what that is around there. To figure that out, picture that being a full circle. The circumference would be pi times the diameter. The diameter is just this distance across here is 8, same as down here. So pi times diameter of 8 is 25.12 feet. Or inches, sorry. Inches. So we add 25.12 over here, which ends up giving us 63.12 inches for our perimeter. Oops, what did I forget to do? This is only half a circle. So we're going to divide that by 2. It's 12.56 inches. So 15 plus 8 plus 15 plus 12.56, that's actually 50.56 inches perimeter. The area of this is actually simpler than the perimeter. Area has 2 pieces, the rectangle and the half circle. Remember, to find the area of a rectangle is just length times width. So 15 inches times 8 inches, which is 120 square inches. Inches squared. Our second piece is the half circle. The area of a full circle is pi times radius squared. Since the diameter is 8, the radius will be 4. So pi times 4 squared, since that is only half of a circle, it is divided by 2. That'll be 25.12 square inches, adding up to 145.12 inches squared for our total area. Questions? Finally, we have volume and surface area. Volume is going to be required. Surface area will be on there, but it will be extra credit. So let's start out with a fun shape, like a cone. This cone has a height of 15 inches, a base with a diameter of 16 inches. We're going to find our volume first. Recall that volume starts out with the area of a base. The base is a circle with diameter of 16, which is at a radius of 8. So that's pi times 8 squared. That is 200.96 inches squared. From that, the volume is an area of a base, 200.96 inches squared, times the height of 15 inches. Volume is always an area of a base times the height. But since this is a cone, it is divided by 3, which makes this 1004.8 inches cubed is our volume. For surface area, we still need the area of the base. There's only one because there's just the one on the bottom. There is not a top base to this. Combined with the area of the base, we need the lateral area. To the lateral area, we need 2 pieces of information. First piece of information is the perimeter of the base. That's this right here. It is a circle. So the perimeter of the base is just the circumference. It's pi times diameter. So pi times 16, giving us 50.24 inches. That's the perimeter of our base. Normally, we use the height as our other piece of information, but since this comes to a point, it's a cone, it would be the same for a pyramid. We use the slant. Remember, the slant is this distance down the sloped surface. To find the slant, we know the distance from that tip down is our height of 15 inches. We know this is our radius of 8 inches. It's a squared plus b squared equals c squared. So 8 squared plus 15 squared equals that slant squared. Now at this point, I'm going to assume you guys can calculate that out and get that slant is 17 inches. So our lateral area is the perimeter of the base, 50.24 inches, times that slant of 17 inches. And because it is a cone or a pyramid, it comes to a point. It forms a triangular type shape. You divide that by 2. So 50.24 times 17 divided by 2 is 427.04 square inches. That's our lateral area. We add those two numbers, giving us 628.00 inches squared as our surface area. Let's say we have a sphere with a 12-foot radius. Remember, volume of a sphere is 4/3 times pi times radius cubed. So for this sphere, it's 4/3 times pi times 12 cubed. This function is 4 divided by 3 times, we'll use 3.14 for pi, times 12 to the power of 3. 7234.56. 7,234.56. And that's going to be cubic feet. For a sphere, surface area is just 4 times pi times the radius squared. So for this sphere, that's 4 times pi times the radius of 12 squared. So that's what, 1,808.34.64 square feet. We're not going to calculate them, but other shapes I might give you to find volume and surface area. Might get a cylinder. It's very possible. I can give you a triangular shape. Might get a pyramid. Might get a box. Any of those are fair game. Last thing we need to review from about a week or so ago. Graphing lines. If I give you an equation, y equals 2/3 x minus 5. Remember, there are two pieces here. The number that multiplies x tells us their slope. That's the last piece we're going to use. The other number is our starting point. That's -5. So on the graph, we always start at the origin in the center. The -5 tells us we go down 5. That is the first point of this graph. From that point, remember the slope is a rise over run. The numerator is the rise, the denominator is the run. So we're going to rise 2, 1, 2, and we're going to run 3. 1, 2, 3. Remember, run is always left to right. Rise is up for positive, down for negative. So there's our line. I might give you y equals 3 minus 1/2 x. The 3 is our starting point. Remember, the number multiplying x is always the slope. That's the last piece we use. That's a +3, so from our center, we count up 1, 2, 3. That is the first point of our line. Now, this is a -1/2 slope. So that means from this first point, we go down 1. The rise, the top number is 1. That's a rise. Negative means down. The run is the denominator of 2. Run is always left to right, so we go over 2. There's our second point. There's our line. Any questions? Okay, well, there is still a new quiz that is due tomorrow at 11:59 p.m. as usual. And there is still new homework that's due for next Tuesday. I will be here till 5:20, so if you want to stick around and work, I'll be here to answer your questions. Otherwise, we'll see you on Tuesday.